Good morning, everyone. Today, our group will present about topic 6, eradication of COVID in the future. Our group have 3 members, Jinhong, Kim, Arun, and me. Firstly, we want to introduce the history and prospects for the disease eradication. The concept of disease eradication originated in the late 18th century when Edward Jenner inoculated James Phipps with the cowpox virus and subsequently infected him with the lethal smallpox virus. The inoculation protected Phipps from the smallpox, demonstrating the first successful vaccination against an infectious disease. In 1998, the Conference on Global Disease Elimination and Eradication as Public Health Strategy in Atlanta defined several levels of disease control, including eradication as follows. Level 1, control, is the reduction of disease in a defined geographic area. Level 2, eradication is the absence of a disease agent in nature in a defined geographic area. Level 3, extinction is the specific disease agent no longer exists in nature or the laboratory. So, when a disease can't eradicated, that means this disease agent is no longer exists in the nature. In history, humans get some success. This is an example of a smallpox patient. Smallpox was the first disease and so far the only infectious disease of humans to be eradicated by deliberate intervention. Back to the present, in late 2019, a novel human coronavirus known as SARS-CoV-2, which is a positive single-strand RNA virus with a nucleocapsid of helical symmetry, has caused an epidemic globally. It's much a question of whether the eradication of COVID-19 is possible. There have been over 8 billion confirmed cases of COVID-19, including nearly 450,000 deaths in June 18, 2020, reported to WHO. In the next part of our presentation, I would like to introduce to you Jinhong Kim, who will be the next presenter.
Hello, my name is Jinhong Kim, and I will talk about what makes the difference between the smallpox and COVID virus. So, since the smallpox virus is the only eradicated in human history, I will compare the features of the smallpox and COVID virus. At first, the smallpox virus is the only eradicated disease in human history, and it is a DNA virus, which means that it has very low mutation rate. Also, the smallpox virus has very unique symptoms, which is the maturation of the makers, the papers, and pustules. Compared to the smallpox virus, the COVID virus is an RNA virus with a very high mutation rate, and it has very common symptoms, including the fever, cough, and fatigue. So, the COVID virus has lots of different features compared to the smallpox virus. As a conclusion, can we eradicate the COVID virus completely? The answer is, I think, no. Although it is impossible to eradicate coronavirus, we can make coronavirus close to be eradicated. To do that, how can we know that some person is a COVID patient? There exists several testing protocols for the disease, which is including the blood test, antibody test, and point-of-care test. And the very standard method is the real-time reverse transcription PCR. I will give the next part will be presented by Arun. Thank you for the listening.
Hi everyone, this is Arun Chhetri. So the slide shows the present approach for viral eradication. The first is identification of animal reservoir. So number of animal experiments are being conducted to pinpoint the viral host, like SARS-CoV-2 genome sequencing in bat and pangolins are found to be close relation to coronavirus, and prohibiting the contact and consumption of such animals' food could reduce the chance of infection. Second is sensitive and specific diagnostic tools, because it helps to diagnose the disease in time. So preparedness for better patient management could be done. And generally, disease symptom is the quick way of diagnosis. For example, in smallpox, sores and rashes, in polio, rapid onset of paralysis are the quick way of diagnosis. But in corona, there is no specific disease symptoms, so it is very difficult to diagnose it on time. And the diagnosis of corona relies on rapid test kits and RT-PCR. So Third is interruption of transmission from one to another. So we all know there's quarantine, contact tracing, extensive community testing, and personal protection like sanitizer and using of face masks are some ways to prevent the transmission from one person to another. Fourth is vaccination. So it is the most effective method of viral eradication. But in corona case, the corona is RNA virus and undergoes a mutation, making this method, that is vaccination, unsuitable. So there is a need of an alternative approaches for corona. Fifth is a political commitment to eradication effort. So all the countries should ensure they have the necessary equipments to prevent and respond to COVID-19. Despite of huge economic loss, we know almost all the countries have stopped any kind of socio-economic activities to prevent the transmission from one to another person. Similarly, many countries are in complete lockdown. And in present situation, this approach is playing a vital role in minimizing the COVID cases. Now, these are the post-eradication challenges. So, although the virus is eradicated, but there are some challenges still after its eradication. First is ensure that the virus stocks and vaccine strains are securely contained within a few reference laboratories in the world. Second, in the era of molecular technology, small viral genomes can be converted to infectious form. And third is bioterrorism, because in the history, different microorganisms have been used in war to defeat other opponents like a bacillus anthrax, botulism toxin, and variola major. Therefore, in present or future, such evil and inhuman activities happen due to the bad intention and ego between the countries. So intensive care should be taken to avoid such misuse of the virus and virus particle or the strain. Now, future approaches for eradication. First is the use of technology such as drones and robots to distribute the medicines and food supply, so the people do not have to go to market or at public places, so there is no chance of spread from person to person. Second is the use of artificial intelligence and mobile apps to trace the epidemics in a real time. So by using a computer technology or mobile apps, then people can predict where the virus might appear, and they could avoid visiting such risky areas. Third is gene editing technology to produce CRISPR B cells, and this CRISPR B cell can produce antibodies of any need. So this is applicable to the virus which do not have a vaccines, as such as COVID-19. And the last, fourth is by synthetic biology, we can alter the genotype of a virus so that the virulence of the virus could be reduced. Thank you. So here are our references.